Okay, geometric series. So, for the geometric series, remember that a series is the sum of the sequence. Okay, and the formula we can use to do this is S sub n equals a sub 1 times 1 minus r to the nth power over 1 minus r. N is the number of terms, and a sub 1 is the first term, and r is the common ratio. Okay, it's all the same things that we've been working with. So let's look at this one. So we have to find the indicated sum for each of the geometric series. So a sub 1 here is 4. My common ratio, you can take that second one divided by the first one, is 5. You could also do 100 divided by 20 is 5. 500 divided by 100 is 5. And n equals 14 because it was given to me. So we're going to plug that all in. So S14 equals 4 minus 5 to the 14th power divided by 1 minus 5. And you get 6,103,515,624. Really big number. Okay? Let's look at this one. So a sub 1 equals 81. My ratio is 27 divided by 81, which is 1/3. And the number of terms is 20. So S20 is 81 times 1 minus 1/3 to the 20th power, all over 1 minus 1/3, which ends up being 121.5. Okay, those are getting smaller and smaller and smaller. That's why that's not the biggest number. Okay. I do not want you to do those next two. 1 second. We are going to do those next two in class. Okay, yeah, we'll do those two in class because in those ones you're going to have to figure out what n is, and yeah, so we'll do those two in class. Reminds me if I forget, because I might, okay? Let's do these ones. So on these ones, it's given us the sigma. So r is always the number being raised to an exponent. In that first one, r is 2. Sorry, I'm like ahead of myself. But r is 2, and we have to find a sub 1. So a sub 1, you plug in the bottom number. So 2 to the 1 minus 1 power is 1. Okay, and n equals 25. So we're going to do S25 equals 1 times 1 minus 2 to the 25th power divided by 1 minus 2, which is 33,554,431. Okay, this next one, we have to find a sub 1, which is 1 again. R is negative 1/2 because it's just the number being raised to the exponent, and the number of values is 8. So S sub 8 is 1 times 1 minus 1/2, 1 minus negative 1/2 to the 8th power over 1 minus negative 1/2. And you get 0.6640625, which can be changed to 85 over 128. Okay, G, so we have to find that first term by plugging in the bottom number, and our bottom number happens to be 6 right here. So that first term is 972. My ratio is negative 3, and the number of terms is 15. Because remember, you can do 20 minus 6, which is 14, but you have to include 6, so you have to add one more, so that's going to be 15. So that's going to be 972 times 1 minus negative 3 to the 15th power over 1 minus negative 3, which is 3,486,784,644. Okay, this last one, plug in 2, you get 1/2. Ratio is 1/2. Number of terms is 10. So S sub 10 is 1/2 times 1 minus 1/2 to the 10th power over 1 minus 1/2, which is 1,023 divided by 1,024. Cool? Okay, so the infinite geometric series. So these ones, there's convergent, which means it approaches a certain value. And divergent means it doesn't approach a certain value. So it goes to infinity. It dies at infinity or negative infinity. Okay? So let's find S sub 1. That's the sum of the first term, which is just 0.5. S sub 2 is the sum of the first two, so 1/2 plus 1/4 is 0.75. Add an eighth to that, it's 0.875. Add a 16th to that, it's 0.9375. Add a 32nd to that, it's 0.96875. Add 1/64 to that, it's 0.984375. This is getting closer and closer and closer to 1. So that means it's convergent. It's approaching 1 value. Okay, this one, first term, 0.5. Add 1, 1.5. Add 2, 3.5. Add 4, 7.5. Add 8, 15.5. Add 16, 31.5. This is just going to keep getting bigger and bigger and bigger and bigger. So that means it's going to infinity. Okay, so there's ways to know if it's going to approach a value and be convergent, or if it's going to approach infinity and be divergent. If r is less than 1, the absolute value of the ratio is less than 1, it's convergent. And if the absolute value of the ratio is greater than 1, it's divergent. Okay, let's do some of these examples. So to find the sum, it has to be a convergent series. You can't find the sum of a divergent series because it's just infinity or negative infinity. But to find the sum of a convergent series, you have to use a sub 1 times 1 over 1 minus r. Okay, so let's look at this first one. The ratio here is 1/4. 1/4 is less than 1, so this is convergent. And we can use that since it's convergent. So a sub 1 is 1 times 1 over 1 minus 1/4, which is 4/3. So if we added this up, the entire series, or the entire sequence, it would be 4/3. Okay, this next one, 8/3 divided by 2/3 is 4, so that's divergent. We can't find an answer for that. This next one, or you do the next two, you should get 14.5 and 5/12 divided by 7. Okay, this next one. So this one, r equals 1/4, which is convergent. So we have -2. Oh, we have to find the first term. Okay, we have to find the first term. So -2 times 1/4 to the 1 minus 1 power is -2. So then the sum is -2 times 1 over 1 minus 1/4, which equals -8/3. Okay, this next one, the ratio is 0.8, and that's convergent. Plug in 1, and you get 7. So this is going to be S sub n equals 7 times 1 over 1 divided, or 1 minus 0.8, which is 35. Okay, this one, 5/2. 5/2, if you take the absolute value of -5/2, it's greater than 1, so that's divergent. And this last one, -3/4. We have to get that first value, so we're going to plug in 2. So -6 times -3/4 to the 2 minus 1 power is 4.5. So that's going to be 4.5 times 1 over 1 minus -3/4, which is 18/7. Cool. Remember to take the quiz. Thank you guys. Goodbye.